Welcome to video tutorials for SILCS Bio. In this video, we will go over how to run pose refinement for ligands with SILCS-MC calculations using the graphical user interface. For this tutorial, you will need the directory with SILCS frag maps for your target. You should have generated this using SILCS simulations module. Additionally, you will need the aligned ligand molecules in STF or Mol2 format that you want to refine the pose for. The information discussed in this video is also available on our documentation website docs.silcsbio.com. Go to SILCS small molecule suite, then go to SILCS-MC docking and pose refinement, then go to SILCS-MC pose refinement, and then go to SILCS-MC pose refinement using the SILCS Bio GUI. Let's start a new SILCS-MC pose refinement project. Hope you have generated the SILCS frag maps for your target. If not, you will have to get those using the SILCS simulations module before moving forward. Now we will go to the SILCS-MC docking and pose refinement section and click on the new SILCS-MC docking project. Next, we come to the setup page. Here we need to provide some inputs or choose some settings as we did for SILCS simulations. First, we need to provide a project name. After that, second, we have our default remote server auto selected. We can change if we want from the drop down menu. Next, we provide the SILCS fragmap directory location. Navigate to your directory where the SILCS fragmap directory is located. Just click on the directory icon without entering the directory and click open. This will automatically select the protein PDB file inside the SILCS fragmaps directory. Then we have the option to choose the input file format for our ligands. If you have a single STF file with all the ligands, choose ligand file option. If you have a directory with individual STF or Mol2 files, choose the second option. Here we will keep ligand file option and use the button below to select the STF file with multiple ligands aligned. With multiple ligands aligned to the known ligand in the pocket. The poses can come from source other than just alignment, for example, a pharmacophore based screening. There are no advanced settings in this case, and we can click the setup button. The command execution window comes up and we can see that a remote directory is created. Then the input files are first copied to local project directory and then uploaded to the remote project directory. When that is complete, we can click the green button, Setup Successful. Next, we can submit the SILCS-MC jobs and track status. On the next page, we can see the paths to our project and inputs. Then in the middle, ligand modifications shows the number of ligands we have provided. And there is a show ligands button on the right for us to preview the ligands before proceeding to the next step. When clicked, the ligands will be loaded along with the protein and the frag maps. We can browse through the ligands if we want. And then now to go back, we click on the SILCS-MC section to the left. Now in the advanced settings, here by default we are in the SILCS-MC pose refinement mode. We can see that the sampling will be done at the center of geometry of the uploaded ligands in this mode. The bundle option allows us to reduce the number of jobs in the queue by combining the individual ligand jobs. Here I'm going to reduce it to 4. We can then check the checkbox for include halogen frag maps since we have the halogen frag maps. Then let's click the Run SILCS-MC button now. The jobs are submitted and then we can click the green button saying Setup Successful. We can monitor the job progress here on the next page. Depending on the availability of the resources on your remote server, the jobs will start running and finish. Now the SILCS-MC pose refinement using the GPU is very fast and takes just a few seconds per ligand. Next, we are going to collect the results and visualize. Let's continue our project through the Continue SILCS-MC docking project option. And as we can see here, jobs are finished and a green show chart button has appeared. And we can click that button now. The LGFE results will get collected in a moment. The best poses and the data in CSV format are downloaded to the local project directory. And then we can click the green button that says data collection finished. This brings us to the next page where we can see the protein and frag maps loaded to the stage and the list of ligands in the chart tab on the right. We can click on the individual ligands and start visualizing their refined poses in the field of frag maps. One can choose to adjust their view of frag maps and protein as they want. And by clicking the atoms, one can start analyzing the atomic GFE values contributing to the total LGFE score for the refined pose. The ligand analysis tab is available for this as described in the Visualizing Frag Maps tutorial. Let's see how the downloaded files look like. To access the downloaded project files, we can start on the home screen and go to the Continue SILCS-MC docking project. Go to our project and click on the Show Project directory on the right. This will open the default file browser for the directory. Here we can see the lgfe.csv file with lgfe and le data for all the ligands. The unsuccessful calculations will have a NaN value if there. Additionally, there is a minconf pdb directory that contains the best poses for all the ligands in both STF and PDB format. One can load them in other visualization tools such as VMD or PyMol or MOE. Thank you for watching the tutorial and see you next time.